Okay, so let's talk about lasers. The word laser is officially an English word now, but it didn't start out that way. The word laser started as an acronym, and it stands for light amplification by stimulated emission of radiation. Okay, so the light makes sense. Lasers are producing photons. The amplification part, we'll talk about what that means. Radiation, a photon is a form of radiation. So really what we need to focus on is this stimulated emission and how that amplifies light. So let's define what that is right now. So we want to know what is stimulated emission. And to understand that, let's first look at a few other things. So the first one will be absorption. For absorption to occur, let's say we have an electron at one energy level, E1, and then we have a photon of energy h nu come in. That electron will absorb that photon's energy, and it will then gain the energy of the photon, and it will move to a higher energy level. So in absorption, the electron moves to a higher energy level by using the photon's energy. Now there's another process that can occur, and this is called spontaneous emission. This is distinct from stimulated emission. Okay, for this process, we are starting with an electron at a higher energy level, and since you always want to move from higher energy to lower energy, that electron can transition to a lower energy level. It's losing some energy, and that energy is converted to a photon with an energy equal to the difference between E2 and E1. So in emission, the electron loses energy, and that energy is converted to a photon. Now for stimulated emission, we have, again, this two energy level system, an electron at the higher energy level, and unlike spontaneous emission where the electron just falls back down to the lower energy level, we will have a photon come in to this system. And let's label this photon as photon 1. And this photon 1 has energy h nu. Now when this photon enters this system, it will be a trigger to cause the electron to fall back down, or fall down to the lower energy level. Now that transition from the between the energy levels is also going to emit a photon, just like in spontaneous emission. But in this case, the stimulated emission case, the photon that's emitted is going to have the same frequency and the same phase as photon 1. So photon 1 is just acting as a trigger for that electron to go from energy level 2 to energy level 1. We didn't absorb that photon, so that photon is still there. Photon 1 is still here. And the electron lost energy, So photon 2 is also produced, and these two photons have the same frequency and the same phase. Now, if the photons have the same frequency and the same phase, we call this, these two photons coherent. Because, if you have the same phase, then these two waveforms, or these two photons, are going to add constructively. And this stimulated emission process, then, is the way that you get lasers to have a very small spectrum. The full width half max is very small because all of the photons produced by stimulated emission are going to have the same frequency. You also see that we're getting amplification in this process. I had one photon coming in, and I have two photons going out. So I increased the number of photons through this stimulated emission process. So this is what the physical mechanism that's producing the light amplification in a laser.